This video serves as a foundational overview of the principles and procedures involved in flying a helicopter. It is critical to understand that this is for informational purposes only, and actual flight requires extensive, certified instruction from a qualified flight instructor in a controlled environment. Helicopter flight is a complex, hands-on skill that cannot be learned from text alone. The fundamental principle of helicopter flight is the generation of lift through the rotation of the main rotor blades. By changing the angle, or pitch, of these blades as they rotate, the pilot can control the aircraft's movement. The primary controls are the cyclic, the collective, and the anti-torque pedals. The cyclic control, located between the pilot's knees, is a stick that tilts the main rotor disc in a desired direction. To move forward, the pilot pushes the cyclic forward, tilting the rotor disc forward and creating a horizontal thrust component. To move sideways or backward, the pilot moves the cyclic in that respective direction. The collective pitch control, on the pilot's left side, is a lever that is raised or lowered. Raising the collective increases the pitch of all main rotor blades simultaneously, increasing lift and causing the helicopter to climb. Lowering the collective decreases lift, resulting in a descent. Importantly, increasing collective pitch requires more engine power to maintain rotor speed, which is managed by a correlator or a twist grip throttle on the collective. The anti-torque pedals located at the pilot's feet control the pitch of the tail rotor blades. The tail rotor's primary job is to counteract the torque effect created by the main rotor's rotation, which would otherwise spin the helicopter's fuselage in the opposite direction. By pressing the pedals, the pilot can yaw the helicopter left or right, maintaining directional control and enabling turns. Before even starting the engine, a thorough pre-flight inspection is mandatory. This involves checking the airframe for any damage, ensuring the main and tail rotor blades are securely attached and undamaged, verifying fluid levels including fuel and oil, and inspecting all flight controls for full and free movement. Once seated inside, the pilot will secure the harness, organize the cockpit, and begin the startup procedure as outlined in the specific aircraft's checklist. This typically involves turning on electrical systems, starting the engine, and bringing the rotor system up to its normal operating speed, or RPM. During this process, the pilot must constantly monitor engine and rotor gauges for any abnormalities. With the engine and rotor systems running normally, the helicopter is ready to begin flight operations, starting with a hover. The hover is the most challenging and fundamental aspect of helicopter flight. To initiate a hover, the pilot smoothly raises the collective until the helicopter becomes light on its skids or wheels. As lift is generated, the helicopter will begin to leave the ground. At this point, the pilot must make small, coordinated corrections with all controls. The cyclic is used to maintain a stationary position over the ground, countering any drift. The pedals are used to keep the helicopter's nose pointing in a constant direction, and the collective is finely adjusted to maintain a constant hover height. This requires constant visual reference and a delicate touch. Transitioning from a hover to forward flight is known as the takeoff. The pilot begins by gently pushing the cyclic forward, which tilts the rotor disc and begins to accelerate the helicopter. As forward speed increases, the helicopter enters a state called effective translational lift, ETL, where the rotor system becomes more efficient due to the increased airflow. The pilot will feel a slight climb and a reduction in power required. The collective is then adjusted to establish a positive rate of climb, and the helicopter is trimmed for forward flight. In cruise flight, the pilot manages airspeed, altitude, and heading using the cyclic, collective, and pedals, while continuously monitoring engine and systems parameters. To land, the process is essentially reversed in what is known as the approach and landing phase. The pilot reduces power with the collective and slows the aircraft by pulling aft on the cyclic, initiating a descent. The approach is typically flown at a steady rate of descent and deceleration. As the helicopter slows through ETL again, the pilot will need to increase collective to compensate for the loss of translational lift. The goal is to arrive at a hover a few feet above the intended landing spot. From this stabilized hover, the pilot then slowly lowers the collective to settle the helicopter gently onto the ground. A running landing, where the helicopter has some forward speed at touchdown, is also a common technique, particularly in confined areas or for slope landings. Throughout all phases of flight, the pilot must be aware of the helicopter's limitations and the critical flight regimes, most notably retreating blade stall and settling with power. Retreating blade stall occurs at high forward speeds where the retreating blade experiences a too high angle of attack, leading to a loss of lift and potential loss of control. Settling with power, also known as vortex ring state, is a dangerous condition that can occur during a steep descent with little forward speed, where the helicopter descends into its own downwash, drastically reducing rotor efficiency and leading to an uncontrollable descent. Recovery requires forward cyclic to gain airspeed and break the vortex. Finally, every flight concludes with a shutdown procedure. The pilot will land, ensure the helicopter is in a stable configuration, and then follow the specific checklist to reduce engine power, bring the rotor RPM to a stop, and secure all electrical and avionics systems. A post-flight inspection is often conducted to ensure the aircraft remains in airworthy condition for its next flight. This entire process, from pre-flight to shutdown, demands continuous situational awareness, meticulous control coordination, and a deep respect for the physics and procedures that make rotary wing flight possible. This text merely scratches the surface of a highly demanding and rewarding skill.